All right, we're going to do a challenge problem together. It says evaluate the expression without using a calculator. Sine of 37 times the cosine of 53 plus the cosine of 53 times the sine of 37 minus 4. And so we're to evaluate that without a calculator. Now, I don't know anything about what the sine and cosine is of angles 37 and angles 53. But as I look at angle 37 and I look at angle 53, I do know something about them. If we sum those two angles together, if I take 37 and I add it to 53, angle 53, it's going to give me 90 degrees. So if you're thinking like Miss Bennett, I am thinking about a triangle, a very special triangle, one that is right? Not the wrong ones. So let's go ahead and use right triangles as a reference, and let's see what we do know about the sine and cosine of these two angles. So I am going to plot in here. I went ahead and I sketched two right triangles, and I'm plotting inside of here what looks like a rectangle, but I'm plotting inside one of my angles. This would be my smaller angle. So that's going to be my 37 degrees. And then I'm going to plot my other angle. This is my 53 degrees. Okay. And now, and I'm going to just make that a little bit smaller so I don't make anyone confused. Let's see, this is going to be degrees. There we go. So now let's talk about what we do know. Well, we know in a right triangle, we know SOHCAHTOA, right? So we can set up some ratios. And for this problem specifically, let's just set up the sine and the cosine of angle 37 and angle 57. Now I'm going to label these both of the triangles, but I'm going to label them with variables because we don't know what the sine and cosine of these angles are. So I'm going to say for the first triangle, which is right here, that contains angle 53, I'm going to say that my height of this is X, my base of it is Y, and I'll call the hypotenuse H. All right. And I'm going to say for my second triangle, the triangle that contains 37, and notice 37 is here too, right? This would be the same angles, but I'm just drawing it down here so you can see it. But I'm going to say for my second triangle, which is here, okay, I will call the height of this X as well, because notice these two heights would be exactly the same, right? So this is going to be X as well, because they're the same distance. And then the base of this is going to be Y as well, because the distance is the same. This 37 is the same as here. It's the same triangle, right? Same length. Now the height, or the hypotenuse, I'm going to call it H again, because again, the hypotenuse length is exactly the same. So let me go ahead and set up my trig ratios using SOHCAHTOA. I'm going to start finding the sine and cosine of angle 37. So the sine of 37 is equal to opposite over hypotenuse. If I go to 37, my opposite side is X. Hypotenuse, we said, is H. So I have X over H. The cosine of angle 37 is equal to, if I go to angle 37, my cosine is adjacent over hypotenuse. Adjacent side is Y, hypotenuse is H. So the cosine of 37 is y over h. Again, we just use variables because we don't know what those values are. Now, let's go ahead and find the sine of angle 53 and the cosine of angle 53. Here we go. The sine of angle 53 would be opposite over hypotenuse. So let's go over here. Opposite side is y, hypotenuse is h. So we would have y over h. The cosine of 53, let's go over here. Cosine of 53 would be adjacent over hypotenuse. Adjacent is x, hypotenuse is h. So we would have x over h. Okay, now I'm going to change my color. Let's do red. Okay, so what do we know about this sine and cosine of these angles? Well, I don't know anything about the values, but using substitution, I know something that's going to help me solve this problem. I know that the sine of 37 is x over h, right? Notice the sine of 37, which is x over h, is equal to the cosine of 53, which is also x over h, okay? And I noticed something about the cosine of 37. I noticed that the cosine of 37, which is y over h, it's equal to the sine of 53. Okay, so I know that the cosine of 37 is the sine of 53, and the sine of 53 is the same as the cosine, the sine of 37 is the same as the cosine of 53. Now, how does this help me? Well, it helps me because if I go back to this problem, I can rewrite this problem in a way where I can solve it. See, I have the sine of 37 here and the cosine of 53. I'm going to go ahead and substitute for the cosine of 53. I'll just substitute the sine of 37 because I know they're exact same. So I'm going to rewrite this as the sine of 37 times the sine of 37. And then if I look at this next one where it has the cosine of 37, well, I see that it's multiplied by the sine of 53. So instead of having sine of 53, I'm going to sub in the cosine of 37. So I'm going to rewrite this as plus the cosine of 37 times the cosine of 37. And then I'll have my minus 4. Now, why did I do that? Well, if I rewrite it this way, I have now substituted for the sines and cosines in order to make an identity, because I know that my identities stand true. Notice the sine of 37 times the sine of 37 is the sine squared of 37 plus the cosine of 37 times the cosine of 37 is just cosine squared of 37. And then if I look at this, guys, I see sine squared of 37 plus cosine squared of 37. I know that's one of my identities. I know my identity says that if I take the sine squared of any angle and add that to the cosine squared of any angle, that just equals 1, right? So all of this here is just 1. sponge. I'm going to go move this down here. So really all we're saying is 1 minus this piece right here, 4. So I know this entire expression is just equal to a negative 3. Now, my question to you, we've solved the problem. We substituted in for the equation, rewrote it as an identity in order to solve the problem. My question to you is, does this stand true for any angle? Can we substitute in and rewrite an identity for any two angles that add up to 90? The answer is yes. As long as your two angles add up to 90, the sine of one of the angles will be equal to the cosine of that other angle. And the cosine of one of the angles will be equal to the sine of the other angle. So when you see your challenge problem, because you'll see it in a couple minutes, you are going to rewrite that problem as an identity and then solve the problem. All right, guys, it is your turn. Good luck, and feel free to message me if you have any questions.